That's wet. Yep, that's battery acid. I don't know if I was recording or not. But anyway, I took everything back apart because I had a few more of the, give her a few more hairy legs. You might hear the inverter going off because I'm running off solar. Real quick, I put some more hair on her legs here. I had to run a few more bodge wires off 976 because it was getting jealous from 177. I also noticed that with the two pals that are rocking, that's where are we at on the camera here? U901 and U902, and this is the D code, of course, and this is the FSM 902. These guys control your IDE bus. Yeah, along with Gary and stuff, you know, but these are your, whoops, programmable array logics for the 4000's IDE controller. And they look like they've been swamped on, so, yep. Check this out. So this motherboard has no Zorro slots. And on the 4000, well, the Zorro auto config on the Amiga is a wonderful thing. It basically, when you turn your Amiga on, this is your hope you learned something moment. When you turn your Amiga on, oh my god, I got these magnifying glasses on, it's just death. Now when you turn your Amiga on, and at least in the 4000, but it has this cool feature that every card, when you turn the machine on, resets to an unconfigured state. And it throws a config in or config out, which you can watch on the oscilloscope, and I'll have to hook it up so we can see what's going on. But on the 4000 Model D, the auto config is actually started and controlled here, because A, this is where the cards plug in, right? And B, well, you can't, I don't know, you can't plug a Zorro card right in here. It wouldn't have the termination or the control chips, and it would be disastrous. But no matter what you do to this card, it won't auto config. It just says no Zorro boards found. You've seen it a couple times. I thought it was a problem with the Super Buster. I thought it was a problem with the gate array. I checked every single pin on all the ICs, minus the bust we had here, and I had some scuzz underneath here. Inside of this board is greener than the bottom of a boat that's been sitting in the lake for 37.5 years. She looks like she was just dipped in green paint. And that's all corrosion. So we're going to use the expensive spray, which is this crap at $17 US per can. Now it says $16.79, I know, but we got this thing called tax. And in my state, it's expensive. Not as expensive as some, but it's expensive. So anyway, this board here has, if you start on pins from the front to the back, so this is the back of the card. Pin, they match, so if you count 12 pins, that's the auto config, and you should get continuity between the 12th pin here and the 12th pin here. And the first thing I did was, I'm getting no beeps, and she's greener, well, she's a little bit better, but she's pretty green in here too. This capacitor has said, I'm not hanging, and I got everywhere. Well, that leaked down here, and I'm going to flip this upside down so you can see it. I'm going to grab one of them pointing devices. There we go. This is one I always stab myself in with. So right here, and where's the camera? You see how she's just ghosting out like some old dried up sugar? Well, that is where the pin goes into the freaking little copper that links it to the other one to start auto config, and right through this guy, C600. So this side looks pretty good. This side, just throw up, just barfing it out there. So while this looks clean, I think it was tanked, or who knows, she's got the original Shoeies in her. I'm gonna do the right thing, just leave them alone for now. We're going to get this 16220 out of here though, and we're going to replace that because I have some brand new Panasonic axials that I'm going to do for that. But first I need to get continuity between these two, and we have some 8-up copper here. Yeah, have to figure out what's going on, but that's where she barfed. So we'll get that all sorted. So that's what I'm working on now. It's been a couple hours, And yeah, figuring out what this thing's on, what this thing is doing has become a real pain in the butt. Troubleshooting Amigas is not a fun task. It's pretty straightforward after you've done it 378.6 times like I have. But every Amiga has its own story. Every Amiga has its own little way. There's revision differences between the different models. Some are easier than others. I don't know if the camera's going to do her any justice. But down in here, I'll try and do some reflectivity. She's just got the swamp ass going. She's just crusty. So this is this board is what I call rusty car syndrome. Looks good till you get her undressed, and she's nasty. But we'll get her sorted. So anyway, that's your lesson on auto config right now. I'm gonna go ahead and repair this trace if I can. If I cannot, my worry is if you put the board in and pull the board out, you could possibly bang that loose or wear it down. That's just fun. And for all y'all that think Shoeies don't leak, look at this. It leaks. See how it's wet? It's wet. Yep, that's battery acid. I did the old. Make sure you wipe your fingers when you're closed. That way the battery acid will eat holes in them. Alright, that's that. Make sure you drop those legs on the floor so when you don't wear socks and pajamas most of the time, you stab yourself in the foot. So there she is. She got a dark one and two more juicies. They're not leaking. I'm not replacing them. Magic Johnson sauce here. Now, deoxit is a lubricant and an oxidation thingy. A little bit goes a long way here. You're thinking, oh my god, I just shot 50 gallons of it in there. Nah. Alright, let's see what happened. Oh, that didn't work. Womp, 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 womp. I know this board works because this is my Amiga 4000 daughter board. Back to the drawing board. We have a working Amiga 4000. We have no Zorro activity. Thought it was auto config, so we had a leaky cap, a screwed up socket over here. So we de-oxidated it, and it'll be fine in a little while. We'll let that kind of soak in, and I'll blow it out. Still going to keep on trucking on. Could be another busted trace. She's got a lot of them. Alright, so I'm booting it with diagram. I think you can press spacebar for NTSC. Finally, it did something. I'm doing a CIA test. It's not detecting the fast RAM. She just stops when you get to the fast RAM. System info. That's fine. What she told me if Buster was working. All boards done, huh? I need to put a crap board in. Like this BSD multi-board. Why did I bring this one out? Because I don't give a crap if I blow it up. It's just the multi-face serial card. Yeah, no boards. It doesn't do anything like that. It doesn't detect any fast RAM. Never does. Never does. Anyway, diagram works. This machine doesn't. It's in the afternoon now, and I just swapped out the Buster chip. This is an 09. I put my Rev 6 from my 4000 in, the multi-face 3 card, just for S&Gs to give her an old test. So I'm going to hook up my keyboard. I don't know why, but we're going to do the 2-finger salute. See if I get any expansion cards. Son of a I'm sick of this. So back to the drawing board. I'm going to take this Buster and put it back to its Rev 9. Alright, we're busting out the big guns. I have it working, but I don't have a low, ouch, a low-high brightness. So we're going to make sure that, there we go, we can get we don't lose our freaking parts, because I always got to stick these back in here because I lose them, because my desk is just clean and I just moved here. Oh my god, I can't see. Let me pause it so I can count the damn. Sucks. I know my CPU works. Signal works. She's not the cleanest, but she's uniform. I am generating a signal. We'll do one more. Ready? Low. High. Data. Okay, it's day 4, 5, something like that. Yeah. Still working on the clock area. I did wire some underneath things. So as you can see, I had to add a couple more wires to the pull-ups here. These are mainly for the mouse and joystick area. They run through these jumpers, which is convenient if you need to make a jump. But the back whole ground plane is kind of eh. So we're going to take a peek at that. I'm going to plop another, that's why I socketed this chip. I'm going to put another real-time clock in here. I don't even know if this is a Ryko. It doesn't have any markings on it, and if it did, they're so worn away from, I guess, previous attempts to repair this board. But I'm going to continue on tracing out this clock. I am missing the diode resistor here that goes from 178 or 177, whichever one the left one is, to the pin here. Here we're still tracing out bad bottom ends of the underside of 177. I just have a dab of hot glue to hold these wires in, so I'm going to go through the continuity of the RTC just to make sure that it is going. It's a tedious, slow process, and I'm using the anti-static bag it's shipped with just to lay it on, because when I work off of my rubber mat here, which is just a cheap floor mat, I usually turn it upside down some on the rubber side so it slides easier. So that's where I'm at right now. It's nothing film worthy. It's basically just me with a small multimeter that'll do RMS or continuity, and when if you don't know, it's just tracing the circuit through. It'll give you a beep. And I forgot about this and I left it on and I killed the 9-volt battery, so I had to go get another one. Still going on this. So I took yesterday off just to spend time with my family and not Commodores for once, but that's what we're doing. So I'm going to continue to trace out the RTC. It's an hour or so later. I've been tracing the pins out on the riser card slot, and the hard drive light wasn't working, so I probed the pins for the hard drive light. I'm using Amiga PCB Explorer. Shout out to you guys who make Amiga PCB Explorer. It's a lifesaver for a lot of us repair folks. So U311 pins 11 and 13. 11 connects to 13, but I can get the 13 all the way across the whole thing through continuity, but 11, she's not answering. There's a little tiny on the board, kind of like a whoop little C jumper that loops 11 and 13 together, and she's kind of burnt slap up. So I'm going to do the right thing, which is the stupid thing, because if I screw this up I will have to take the socket off, and I don't feel like doing that. So we're going to take hot air, and first I'm going to captain tape the area off around the SIM socket so I don't burn it, because I don't feel like having to take it off. Now sometimes you can just boil these out and they'll come free. So there's your girl. She's hot and it has some crust underneath. Go figure. This whole thing is just smashed with battery acid. Let me clean this up. The area we're talking about is this mess right here, and that is where the hard drive light is controlled from, believe it or not, or part of it on the LED signal. So we got the 7407 cleaned up. So where this comes in, I'm good from here to here, but from here to here, nothing, and the SIM is right over top of it, and I can't even check the trace, but I don't have any continuity, and I will triple check myself. What I'm going to run a small wire on the inside here and kind of whoop, and then stick the chip back on top of it. Repairing 177 took several days, and it's not like I'm sitting here for at least 4 hours a click on this thing, and it's well, it's been almost 2 hours right now, and I just kind of get burned out of sitting here looking through magnifying soldering goggles. And once I get this fixed, we're gonna test it again. I pulled all the fast RAM out, as you can see, just left the chip in there so I didn't heat it up or too much, but I don't need this right now, and well, that's a good spot for it. And we'll soldier on. The chip would sit up too high with the wire underneath, so it's going to have to be fugly and on top, which doesn't really matter at this point. And through the magic of editing, there it is. I actually had to scoot this chip out this way, just a little bit, I stabbed myself in the hand so I could get a little bit more room in this side to zap that on and get all these pads back on and clean it up and just do continuity testing, and yay, now the hard drive light should work. All that for the hard drive light, and that's a pain in the butt. Whew. And I flipped my mat over because this thing has the copper on it still, and I have cut myself probably 437,826 times on that, so that's what I'm working with. Let's see, where did I leave off? I was testing the Zorros on the left side. I haven't even done the right side, or this one, or that one. So we're getting there. I'm just testing everything. No clock detected. I didn't do the chip yet. So something is still not doing the full reset. So we got ourselves a brand new Ryko RP5 C01. I run the alphas because it's a replacement chip for the RP5 C01. No clock detected. Fudge. So on the right hand side of the motherboard here, right around 177 where all the spaghetti sauce is, and that wonderful camera, we're going to set this on voltage DC, and these should be 5 volts. So the left side here, before I knock this over, is going to be 5 volts across the rail. So 4.96, and here we go. I need to see it too, you know. I need to see it. I'm the one working on it here. Come on! Alright, so second one, 496. Nothing? That's dead. That's dead. That's dead. That's dead. Oh, wait a minute. 496. 496. Scratching? Let me check the rail here. Just, nothing. So I might have to do some little small... Oh, that one's got one. 496. 496. 496. 0.01. But the outside pin has... Yeah, and this one is 496. So I have a couple of them that are really, really screwy. Let me fix those. We're back after, I don't know, 6 or 7 hours. Haven't been working on it for 6 or 7 hours, but I've just been repairing more traces that I keep finding broken. I noticed something weird. So I fired mine back up, and on mine, my chipset ID, the Lisa, says FCF8 for Denise Lisa, Alice Agnes 0033. Look at this one. FFF8. And then 0033. Mine, battery backup clock works. This one, battery backup clock not detected. And also, the riser cards are like nothing. Everything works. I mean, only got one RAM chip, so, you know, CIAs, they're all tested normal, but this FFF8, AGA Alice with bad Lisa ID. Grabbed a 5 volt from the 5 volt rail right here on top of the pull-ups. I bridged all of these together because my 5 volts were screwed up, and I figured they're all 5 volts. They're all coming off the same feed and vias underneath, and they're all on the same line. Why don't I just bridge all these together? So I did. That's when the weird chip ID thing happened. 5 volts. So we'll go out. Whoops. There you go. FFF8, right? Take that off. Let's get it out of the way. Go back in. F0, F8. So I have to get 5 volts somewhere else. So that was my idea. I saw that pin 16 was 5 volts and 100 nanofarad underneath on 177, and I figured I'm just gonna grab 5 volts from the rail and that'll be groovy, except it just ended up causing me problems. So alright, so we got some more wires repaired. We got ourselves a daggone highway one here. We got one running from 4, well, never got it in there, but it's kind of, well, it fell out, but it's all the way down here, all the way up, because it goes past the poop part. So I'm going to resolder this in. So we're getting there. She's still got the sparkle on her, but she's a mess. The whole resistor pack here, pull-ups, they're gone. I did manage to save one of the traces through here. The other one was a long one, that's why I just ran the wire, hell with it. I'm going to clean these up. I have to get these vias poked clean because they're full of yuck. I got one done and they feed, and the bridging that I did just did not work correctly, causing issues. I want to do it right and clean this up proper and just do wires through each one. Solder them in and it won't look too bad. So that's where I'm at, and it's been a couple more hours. Hello, Amiga 4000, day 478. The board of glass, as I've so come to call this, is just crumbling before me. My main issue is this area around, this is the bottom side of the board. I was just doing some resistor values for the two 1Ks and then the 4.7s, and they're supposed to have 5 volt on one side. There's a via and then the resisted value on the other side that goes to 177, 976, and 975. On this side of the beard, she's just destroyed. Every time you touch it, it just falls apart. I'm going to probably have to replace all these resistors, but I'm scared to take them off because the whole area is really badly damaged with battery acid. I've neutralized it, but you can still see the light green around a lot of the parts. 891 is functional, but she's got some bloom, I guess you'd call it, underneath of it. I removed the clock chip. I removed the resistor pack when I had to manually wire 177 back in, and I replaced 976 because it was green as a daggone. That's 177. She's around here somewhere. It was greener than the bottom of the Titanic. Here you go. I don't know if you can even see that, but it's pretty bad. This board is just a nightmare. So it'll boot right up here, and I have to use the mouse because I don't have it. I have this weirdness on this side. Now, these are the resistor values that I'm getting. On each side, this is the bottom and this is the top. It's supposed to be 5 volt, a via, and then 5 volt on the top. I'm getting 5, 5, 0, 4, nothing, 5 on the bottom one. So these two are working. This one's working. Everything else is shot. Just gone. Because the holes are just so ate up. Now I'm going to zoom in on this one more time to let you see just how bad this area is. And this entire area, there's a via right here. See these little holes? Well, that's where the 5 volt comes. There's a little trace that touches this side of the resistor. Right? And they're, 47 kilo ohm, 4.7s, a couple 1Ks. Nothing major. They're just surface mount. They sit on a pad, and you solder between each bridge point. No big deal. But all of these traces are busted. I'm like, no big deal. I'll just run a wire and bridge them all. You can't do that because I don't know why. They have to have an independent 5 volt resistive source somehow, because every time I would bridge these to get a constant 5 volt across, I get that weird invalid Lisa DMA ID or whatever it was saying. This board is just so bad. If you just touch it, like if I just touch this area, it just comes apart. So I'm just extremely hesitant about even touching this. My idea now is, since these vias are just toast, I think they're etched into the ground plane in between. Remember, these are quad layer boards, so it's a 4 layer, but they're only using basically 2. There is a ground plane and in the middle, and I think something happened to this, so I can't pass wire through it. I could drill it out, put a new through hole in. It's just such a pain in the butt. I might even just wrap wire as a test around a shielded wire like I've been using, just the normal you know, this stuff to just go independently from resistor pad to resistor pad. It might be uglier than a $3 bill, but I need to isolate these signals. For some reason, every time I bridge the 5s together, it's just, she's just gone. All of the copper that goes to the via is gone. I have a ring on some, as you see down here. She is just so tore up. I have barely a pad left, and I had to make my own to the resistor point, and ironically that works. I mean, functionality over fashion is fine by me, because this will all be hidden in a beautiful Amiga 4000 case when it's done. So that's where I'm at. I have to fix this area,